Hello students, welcome to Akshara 8 Foundation. Myself I am Shivashankar, I am a physics teacher. So today we are going to discuss continuation of last topic, that is we have discussed the final velocity of objects which are collided uh, of first body and second body. Okay. So now we have got the formulas yesterday, the formula I write here. We got the formula V1. V1 is equals to so here we got there m1 minus m2 divided by m1 plus m2 into u1 plus 2 into m2 divided by m1 plus m2 into u2. Okay, that is the velocity of the first body after the collision. Okay, and second one we got here v2 is equals to, we got there, so 2 into m1 divided by m1 plus m2 into u1 plus here m2 minus m1 divided by m1 plus m2 into u2 we got there. Okay, so by using these formulas we have the different cases there. Suppose here different special cases we can see there, special cases. Okay, so first one we will see here. Suppose if so first case we will see here, that is if m1 is equals to m2, okay, so if m1 is equals to m2, what happens here? Okay, so then what is the velocity? Final velocity will become what happens there, we can see here. So if m1 is equal to m2, this value will become 0 here, v1 is equals to, what will happen there, m1 minus m2, this will become 0, this total value will become 0, and here we will get there 2m2 divided by here m1 plus m2, so 2m, okay, so 2m2 divided by 2m2, so we will get what there here, u2 will get there, u2 means the final velocity of the first body will become the initial velocity of the second body. Okay, it will be exchanges, velocities can be exchanges there. So now next one v2 will become, and v2 what will happen there, v2, so here it will become this value will become 0 and it will be, so v2 is equals to u1 will get there, v2 is equals to u1. Okay, so v2 will be equal to u1. Okay, then so next case we'll see there, if m1 is equals to m1, so second case here, if m1 is far greater than, so m2, this m1, if m1 is more greater than m2 there, if m1 is more greater than m2 and lighter body is at rest there, lighter body means here, and m2 is at rest, so lighter body is nothing but here, lighter body m2 is at rest, m1 is greater than, so this is at rest, so if it is at rest, u2 will become 0, no, u2 will be 0 there, so u2 value will be 0 then. What will happen here, v1, so v1 is equals to, what will happen, v1 is equals to, so it is far greater there, so m1 more greater than, so m2, no, if it is more greater than m2, then m2 is at rest, this one, m2 lighter body is at rest means this will become 0, this total value will become 0 here, so we'll get here m1 minus m2 divided by m1 plus m2. So if it is far greater than m1, the v1 is equals to, so v1 what will get here, this is a more greater, no, if it is a more greater and m1 is greater than, then here we'll get there m1 minus m2, so far greater than means we can write here it is 2 double, and here m1 is more greater than means v1 is equals to, we'll get here v1 is equals to v2. So V1 is equals to V2 will become there. So V1 is equals to here U1. This will become U2 will become 0. If U2 will become 0 there, so V1 is equals to what will get here? V1 is equals to U1 will get there. U1. U1. So this is M1 is more greater than no, then this will become M1 plus M2 divided by M1 plus M2 will get here more greater than here we will be right here V1 is equals to U1 we can write that. V1 is equals to U1. So next one, so V2 is equals to V2. What is the V2 here? V2 is this one no? So V2 will be equal to here. So this will become M1, M2 is at 0 means this value will become 0 here, and this one V2 will be equal to, V2 is equals to, this is a more greater there. So if it is a more greater, then the velocity will become here, this is a M1 is greater and this is a M1 plus M2 will become no, M1 plus M2. So it is almost then we will be right here V2 is equals to 2 times of U1, 2 times of U1 it will be, 2 times of U1 means, so M1 is greater, okay, M1 is greater and it is moving with velocity U1 and M2 is at rest there, M2 is at rest, then final velocity of the second body, final velocity of the first body will become U1 means it will become initial velocity, okay, it will become initial velocity and second one is 2 times of the initial velocity of the body, okay, that one. And next third one, so next case, third case we'll see here, third case, that is if M1 is lesser than heavier body, so M1 is far lesser than, M1 is more lesser than M2 and so heavier body is at rest now, so this M2 is at rest there and M2 is at rest means, so M2 is at rest means here M2 is at rest, M2 is at rest, if it is at rest then U is equals to, U2 is equals to 0, okay, U2 is equals to 0. So now if you substitute there in the above formula there, V1 is equals to, so V1 formula is what? This V1, M1 minus M2, M1 minus M2 divided by M1 plus M2 into U1. So this total value will become 0 there, U2 value will be 0 and here M1 is far greater than means here we will get the negative value, no, we will get negative value there here, okay. So negative value will get here, so that is V1 will get minus U1 will get, V1 is equals to minus U1 and V2 is equals to what will get here, V2, so V2 formula is what, here we can see this one, no, V2 formula is this one, so this is a M1 is lesser than M2, M1 is lesser than, so this total value will become 0, okay, this value will become 0 there here, so M1 is lesser than M2 means, so it will be V2 will be equal, almost it is equal to the U1, V2 will be equal to, V2 will become to the this one, see here this is a 2 M1 V2, U2 is 0 means this total value will be 0 here and then so 2 M1 by M1 plus M2 into U1 is there, so V2 will become, so and here V2 will become here 0, V2 will become 0, that will becomes to the rest, that body will come to the rest there. Next case, collisions of two billiard balls, okay. Billiard game will be there, no, in that collisions of two billiard ball, two billiard balls, collisions of two billiard balls there. Okay. So here we have m1 is equals to m2. All the this billiard balls will be equal mass. They have all equal mass. Okay, and one will be at rest. Suppose here u2 will be 0. The second mass will be 0. Then, so what is the final velocity? What will be the final velocity? So here in this first second mass of the body will be 0 there. So then here v1 is equal to what happened there? It is 0 means m1 minus m2 will get no, that is 0 and that is 0. So here v1 is equals to will get 0 here. v1 is equals to 0. The next one we have here. So v2, what about the v2 here? v2. So v2 means u1 will be there here. So that will be here. This v2 formula is what? This 2m1 by m1 plus m2 no, into u1, and this value will become 0 here. u2 is 0 there, and here m1, 2m1 divided by m1 plus m2 is there. u1 is there no, so it will become there. Masses are same there here. So it will become v2 is equals to v1. v2 is equals to u1 will get here. So v2 is equals to u1 will get. Okay. So these are the case of billiard ball. If light projectile collides with the varying heavy target, so next case is if light projectile collide with a very heavy target there, means m1 is lesser than m2. m1 is lesser than m2 there. So in that case we have seen there. m1 is lesser than m2. So in this is the first one, and second case we will see here. Second case, m1 is lesser than, very lesser than m2. m1 is lesser than m2, and very less. See here also we can see if it is a very less means we can neglect. No, m1 can be neglected there. If m1 can be neglected, what happens here? If m1, this m1 is very far greater than m2, then m1 can be, we can neglect m2. Then, so v1 is equals to what happen here? v1 is equals to. So m1, if you neglect m1 there, v1 is equals to will get here. So v1 is equals to, v1 is equals to, v1 is equals to here. m1 is far lesser. This is a far means this can be, if it is far lesser, then so m2 can be taken as here 0. Sorry, m1 is can be, m1 can be written as here 0 there. Okay, m1 if you write 0, then v1 value what we get here? v1 is equals to, v1 is equals to. So substitute in that formula there. v1 formula is what there? m1 minus m2 divided by, so m2, so m1 m2 if it is neglected, then minus m2 by m2 will be there, minus u1 will be get, and here so 2 u2 will be there, 2 u2. So u1 plus u2, u1 plus u2 will be there. So here this can be written as here u1 plus 2 u2. This we can write here minus u1 plus 2 u2 will get there. This is the final velocity. And next v2. So what is about the v2 here? v2 means 2m1 divided by m1 plus m2. So if it is neglected, then v2 is equals to, v2 is equals to, v2 can be written as 2 times of u1. v2 is equals to 2 times of u1, and m1 is here in this second, this one. So m1 if it is neglected here, this m1 and m1 will be cancelled there. If it is neglected here, u2 will be present, and m1 if it is neglected, this will become, if this 0, this total will become 0 there. So then v2 is equals to u2 will become there. v2 is equals to u2. v2 is equals to u2. Understood no this one? So in this also, here also, if m1 is far less than here m2, this m1 can be equated 0 there. If you equated and you substitute in that equation, in the v1 and v2 equation, we will get these equations and this equation. Okay. So now next one, we are going to see their next case. Next application, if a body of mass m1 moving with velocity u1 and collides elastically with a stationary mass m2. Okay. So means u2 will be 0 here. Okay. So here the next case, if next case here, next one, if m2 is equals to 0, means not m2. If m2 is at rest, m2 is at rest, m2 is at rest, then u2 will be 0 here, u2 will be 0, and then so v1 will get here, so v1, and then m1 is here, mass is, then they have the different masses there, comparable masses, not it is far greater than or lesser greater than, then it is comparable to the certain values are there. Then here m1 minus m2 divided by m1 plus m2 we can write now, m1 plus m2 into u1 we can write there, and then final velocity, and the final velocity is what happened there, v2 is equals to, u2 is at rest means that will become 0 there, here 2 into, so m1 by m1 plus m2 into here u1 will be there. So now the kinetic energy of the first body, here we can write the kinetic energy of the first body, what can we write here, half into m into v1 square, so half into m into v1 square, no, so we can write here half into m into, so here the first body, so we can write here m1, here this also we can write m1 value, what we got here now, this one, so m1 minus m2 divided by m1 plus m2 into whole square, whole square will come here, u1 square will come there. Okay. So therefore the kinetic energy of the first body, after collision, kinetic energy of the first body after collision. Okay. So here we'll get the, so half into m1 u1 square into m1 minus m2 divided by m1 plus m2 whole square, m1 plus m2 whole square we can add there. Okay. So this is the kinetic energy of the first particle after the collision, kinetic energy of the first particle after collision. So this is K1 we can add there. Now kinetic energy of the second particle, what can we write here, half into m2 into v2 square. So here we can, what can we write here, half into, so m2 into v2 is nothing but this whole thing, no. So we can write here u1 square we can write directly, and 4m1 by, so m1 plus m2 we can write there. Okay, m1 plus m2 we can write there. So simply, therefore the kinetic energy to second body, kinetic energy 2 can be written as here half into, so m1 u1 square into 4 m1 by m1 plus m2, 4 m1 by m1 plus m2. This is a kinetic energy of the second particle, there. So now change in kinetic energy, here change in kinetic energy. So change in kinetic energy we can write here, kinetic energy, initial kinetic energy, body will be get here, K2 minus K1 we can write here, K1 minus K2 we can write down. No? So here which is the mass, if they are comparable, no, so then kinetic energy get given by the body. So we can write here it is, this is a 2, this one whole square will come there here, this is a 2 into whole square, this also here 2 into whole square will come there, this one m1 u1 square, no, so square will come there. So this is here not 4, this is a 2, here it is a 2 m1 whole square will be there, 2 m1 whole square. Now if we write the change in kinetic energy, what can we write here, delta Ke is equals to Ke2 minus Ke1 will write there, so Ke1 minus Ke2, or so initial kinetic energy, final kinetic energy. So that is equals to, here we will get this one, what you get there, half into m1 u1 square into, so this will become 4 m1 square divided by m1 plus m2 whole square, m1 plus m2 whole square we got, minus here, so half into m1 u1 square, here we got there m1 minus m2 divided by m1 plus m2 whole square we can write there, whole square. Okay, so now so change in kinetic energy K2 KE2 minus KE1. Okay, so KE2 we know that half into m1 u1 square into 4 m1 square divided by m1 plus m2 whole square. Next here half into m1 u1 square by m1 minus m2 whole square divided by, so m1 plus m2 whole square we can write here. So now from this we can take here common, half into m1 u1 square if we take common, which is the remains there, here remaining value is this one, no? So divided by here, even we can take here, okay, m1 plus m2 whole square, m1 plus m2 whole square we can take here, and next remaining is here m1 minus m2 whole square divided by m1 plus m2 whole square. Okay, m1 plus m2 whole square. Now from this even we can take here half into m1 u1 square if we take common, divided by this m1 plus m2 also if we take common, whole square. Okay, this one if we take common here, if you take common, what is the remaining here now here? So 4m1 square minus here m1 square minus m2 square. So we'll get here plus 2m1 m2 will be remain there. 2m1 m2 will be remain. Okay, that only we got now in this previous problem. So here m1 u1 square, here also m1 u1 square we got. So here m2 u2 square. Sorry, this one is a m2 u2 square, no? m2 u2 square, and here m1 u1 square. So now here we will be get in this second equation. This is the second one, no? Here we will get there. This is a m2 u1 square. So here we got no same m2 u1 square. So we will be get there here. So m2 u1 square. So here also it will be get m2. So then we can take from here. We cannot take common here m1. So this equation will write once again there. From this we can write like this now. Now here from this one we can write this also. This equation we cannot write it. See, from this half into so this will be, we can write here half into u1 square we can take common, half into u1 square if we take common from the both we will get here, here u1 square is there, here u1 square there. So here we can get there 4 m1 square m2 will get 4 m1 square m2, and here we will get there minus, okay, minus m1 into m1 plus m1 minus m2 whole square, m1 plus m2 whole square will get, and from this half into u1 square is there, u1 square, and here 4 into m1 square m2 minus, we can write here m1 here m1 into this we can write here m1 square plus m2 square minus 2 into m1 m2 we can write here minus 2 into m1 m2 we can write like this. So now from this and divided by here whole divided by, so m1 plus m2 whole square will be remain m1 plus m2 whole square here also. So m1 plus m2 whole square can be remain. So here now we can write here 2 into u1 square 2 into u1 square. So here it will be remain like that 4 into, so m1 square m2 minus, so m1 m cube will be there here, so minus m1 m2 square, and here minus and minus plus will get there 2 into, so m1 square into m2 will be there 2 into m1 square into m2 divided by, so m1 plus m2 whole square will get there. So this is a change in kinetic energy will get there, change in kinetic energy. Okay, change in kinetic energy. Okay, change in kinetic energy expression will get that one. So now based on this we have the numericals. Based on this, all the formulas will be have the numericals. We'll see the numericals then. So then first one, see concept based questions are there. First one we'll see now. In an elastic collision, correct one is momentum. See, in the elastic collisions, both kinetic energy and linear momentum will be constant. No? In elastic collision, both kinetic energy and the linear momentum will be constant. And perfectly elastic collision, so of ball P1 of mass m1 moving with velocity v collides elastically with three exactly similar balls. So one ball P1 of mass m and it is moving with velocity v1 and collides elastically with three exactly similar balls P1, P2, P3 and P4 lying on a smooth table. Velocities of four balls after all collisions is, what is the velocity of those particles there. So it will get there third one. So remaining all the velocities will become 0 then, and it will be fourth one will get the velocity there. Okay. Suppose like here 3 balls. Suppose this is the same mass of the ball and here 3 balls are there. No, like this 3 balls are there. 3 balls will be there here. Now if it is collide here, this will be go and it will be stop. This will ball will be stop. This will be stop and this will be stop. The final velocity will be go with the 3 other balls. 3 other balls, no? So final velocity, this one will be get the velocity there. So this 3 will become 0, this will become 0, this will become 0, final velocity will move with certain velocity there, okay, like that. So next one, if the direction of velocities of two bodies are same as before, after collision, that collision is said to be, okay. So direction of is same there. So one dimensional collision we can say, that means after the collision, if the objects are moving in the same direction, okay, then they are said to be the one dimensional collision. So in elastic collision, the kinetic energy after collision, in inelastic collision, the kinetic energy will be lost, no, it will be lesser than the initial kinetic energy will get there, okay. So next fifth one, in any collision, which of the following is conserved, okay, in any collision, the linear momentum will be conserved there. Whether the kinetic energy is conserved or not, but linear momentum will be conserved. The quantities are remaining constant in an elastic collision are, so momentum and kinetic energy and temperature. Momentum and kinetic energy and the temperature. And next one, the heavier body moving with certain velocity collides head on elastically at a lighter body at rest than which of the following is true, okay. So lighter body, heavier body is moving with certain velocity and collides head on elastic lighter body. If it is elastic lighter body, then second body will be move with same direction, okay. Heavier body will be moved with same direction with velocity along the same direction. Lighter body will be moved twice the velocity of the initial velocity and heavier body. So both 1 and 2 will be come there, okay. Both 1 and 2 will come there. In one dimensional elastic collision, the relative velocity of the approach before collision is equals to relative velocity So relative velocity means relative velocity is nothing but velocity of approach is equals to velocity of the separation, we can write there. That is the first option will come. Two identical bodies moving in opposite direction with same speed collided with each other. If the collision is perfectly elastic, two identical bodies moving in opposite direction, they are moving towards each other, they are approaching with each other, then collided each other, the collision is perfectly elastic. Then after collision, so they will be recoil in the same direction there. So after collision, if the same velocities and they are coming in the same direction, after collision they will be move in away from each other there. Okay. So that is about the concept based questions. Now we will see the exercise 1, exercise problems there. Exercise problems, exercise 1. So first question you see here, first question. A ball of mass 0.5, here m1 is given there, m1 is given, m1 is equals to 0.5 kg, m1 is equals to 0.5 kg, and v1, u1 is given, it is moving with the speed of 5 meter per second there, 5 meter per second, and collides with the another ball of mass 1 kg, collide with another mass of the ball 1 kg, so m2 is equals to 1 kg we can write here, and that will be have the velocity u2, it has a velocity u2, it is moving, suppose it is moving with velocity u2, and after the collision they will be combined and they will be travel with the speed, they have said here v2 is equals to 0. Okay, so not v2, after the collision they will be stick together and it will be comes to rest there, means final velocity we can write here. So v is equals to 0 here, v is equals to 0. Now what can we write here? According to law of conservation of linear momentum, we can write here m1 u1 plus m2 u2 is equals to, so after the collision they are combined and moving, no, m1 plus m2 into, so here we can write there v, so v how much it is there, 0, no, so we will get here m1 is how much then, m1 u1 plus m2 u2 is equals to, this will become 0 there because this will be 0. So from this we can write here, so m1 is 0.5 and this is a 5 plus m2 is what here 1 kg and this is a u2, so is equals to 0. So then here this will become at 2.5 we can write, 2.5 is equals to minus u2 we can write, therefore u2 is equals to, we will get there minus 2.5 meter per second. Here if you take, means minus indicates it is moving in opposite direction. Minus indicates it will move in opposite direction. That means it is half of that, no? So half of that will be move in opposite direction there. Okay. So next one, second one. A man, so 60 kg man, a 60 kg man. Second one, a mass of man is 60 kg, is moving skating with a speed of, so u1, so m1 is equal to, it is given there 60, u2 is equals to moving 10 meter per second and collides 10 meter per second and collides a man of m2 40 kg which is at rest. Okay, skater at a rest there. So he is at rest means u2 will be equal to 0. u2 will be 0. If u2 is 0 means what can we write here, u2, and the loss of kinetic energy during the collision is loss of kinetic energy. After that they will be stick each other. Okay, so after the collision they will be stick together and they will move there. Okay, so then here according to law of conservation of linear momentum, m1 u1 plus m2 u2 is 0, no, that is equals to, here we can write there m1 plus m2 is equals to v we can write here. Okay, then how much will get here, this will become 0, then 60 here, 60 into 100 will get, that is equals to, so it is a 100 into v we can write here. So now what is the velocity we will get here, v is equals to, we'll get there 6 meter per second. So after the collision it will move with 6 meter per second there. After the collision, so the body will be moved with this velocity. So it will be stick together and moving that velocity. So with 6 meter per second velocity, it will be more there. Then loss in kinetic energy. Loss in kinetic energy. So what can we write here? Loss in kinetic energy. This is kinetic energy 2, no? Kinetic energy 2, we can write here. So that is equals to, so half into here, 40 into, so this is a 6 whole square, 6 whole square. That is nothing but how much we get there here? This will be 20 and this is a 36. How much we get here? 36. 20 into 36. 20 into 36, how much? 36. We will get here. How much this one? 72. 720, no? 720. 720 will get there. 720 joules. 720 joules. It is K2. Then K1. K1 we can write here. So K1 720. And okay, here after the collision, see K2, after the collision they are stick together and moving, no? Then the final kinetic energy we should take here, even we have to consider this also. So here we should consider like this. So K2 half into M1 plus M2, M1 plus M2 into V square we should write there here. So half into M1 plus M2 means it is 100 will come there. 100 into, this is a 36. 100 into 36. So we can write here, this will be the 1800 will get, na? 1800 joules. So the K2 is equals to how much you get there? K2 is equals to, so 1800 joules. A K2 is equal to 1800 joules will get there. K1, how much you get then? K1 is nothing but initial kinetic energy. That is a K1. K1 is equals to half into M1, how much there? 60. M1 is 60 into U1. This is a 10 square. 100 will come there here. So this is how much? It will be the 30, no? Initial kinetic energy. Second body is at 0. So that can be 0 means it is a 30. So we'll get here 3000, no? 3000. So K1 will get here, Ke1 is equals to 3000 joules. So then change in kinetic energy. So change in kinetic energy, delta Ke is equals to Ke1 minus Ke2. So change in kinetic energy, how much there? So we can write like this, no? So delta Ke is equals to Ke1. So Ke1 minus Ke2. Ke1 minus Ke2 we can write. This is a 3000 joules minus 1800 joules. So how much we get it here now? This will be the 2. Okay, we'll get here 1200 joules. So delta kinetic energy will be 1200 joules we'll get here. Okay, this one. Okay, that is the second one. So like that even we can do the second one, third one also, fourth one also. A smooth sphere of mass we can do. These all the problems we can do like this only, by this problem only. So we can you can solve this all the problems there. So here 10th one, I'll see these all the problems are up to 9th one, there are same problems like this only it is there. 10th one you see it is a different there, they are asking the mass of the second body. So that problem we can find out like this. So 10th one we will see there, it will be the different problems, we should find out the mass there. So M1 mass is given here, M1 mass 6 kg, M1 mass is given 6 kg and makes an elastic collision with another body which is at rest there. So another body, so M2 mass, another body, this is a, we don't know the mass, that we need to find out there. This is at rest, they said there here, this is at rest. Okay. And first body then moves in the same direction with first body moves in the same direction with its speed reduced to 1/2 second body. Second body moves in the same velocity as that of first body, then mass of the second body. So after the collision, what happens here? V1. So V1 is reduced to. So let us consider this is a U1 is a U, we can write here. U1 is U. And after collision, the velocity of the first body moves in the same direction. First body then moves in the same direction with its speed reduced one half. Okay, means here we can write there it is reduced to one half there. Reduced to one half means so u by 2 it will become there, u by 2. Okay, so then next one said they what they are saying, next one, next body is second body moves with same velocity as that of first body. Second is moving with same velocity as that of first velocity, means so v2 is equals to u, v2 is equals to u. Now, so we can write here now law of conservation of linear momentum we can write here. So that is m1, so m1 u1 plus m2 u2, m2 u2 is equals to, here what can we write here, m1 v1 plus m2 u2, m2 u2 m2 v2 we can write here, m2 v2. So what it is given here, so this is a 6 kg and u 6 kg u 6u plus this is a this we don't know, m2 into here we can add there 0 plus m1 is what, 6 into v1, it is become there u by 2, no, it has become u by 2, in the same direction it is moving there, in the same direction. So this is m2 is we should find out there, m2 value we should find out, and this is a u, it has become u there. So now what it will be there, here 6u will be there, so this is a 3u plus here m2 into u, m2 into u. So in all the terms what is the common there, u is common there, we can take common and cancel there. Then if you bring here m2 will become, m2 is equals to 3 kg, m2 is equals to 3 kg. Like this we can do all the problems. Okay, so remaining problems we can continue in the doubt session. Okay, with this we have completed the center of mass topic. We have completed center of mass topic completely. Okay, one more topic is there, it is the last topic, this will be seen in the next class. Okay, thank you children, have a nice day.